One thing good about online class, you can join just on the dot there. They have to class, let's say 5 minutes early or whatever early. Okay, it's now 12 o'clock, so I think we shall start our tutorial class, shall we? How many of you supposed to be in this class? 14. Okay, a small class. All right. 14 of you. I think I have 13 now, so we shall start our class. All right, I think we are left with a few questions in tutorial 3, right? All right.
Yes.
Yeah, so I believe for your group, I haven't even started question 1 with you, have I?
Yep.
Yeah, okay. So I think after going through all the rest of the questions, the question 1 and 2 should be relatively easy already lah. Okay, so let me share my screen first. Okay, so in tutorial 3, question 1, we have an 800 hertz 3 volt. Can you see my screen? Can I?
Yes, Miss.
All right, good. So we have an 800 hertz 3 volt modulating signal in an FM system produces a deviation of 6 kilohertz. If the modulating voltage is 6 volt, what is the new deviation? All right, so basically when you are given a requirement or questions, you should actually quickly find out or identify the information that is given. All right. So we have here 800 hertz. 800 hertz, what is this? It's a frequency, isn't it? So it's a frequency of our modulating signal. All right. So frequency of a modulating signal, then straight away um, we can say this is FM, right? The F, small f and subscript M, okay? So that is the frequency of the modulating signal. And 3 volt, 3 volt is a voltage. So that is the amplitude of our modulating signal. So amplitude, we normally use Vm, isn't it? Yeah, V subscript M. So this signal produces a deviations of 6 kilohertz in our FM system. All right, a deviation of 6 kilohertz. So kilohertz, hertz is a frequency, right? So that means this is a frequency deviation. All right. And the symbol we use for frequency deviation is delta F, isn't it? Right. So this tells us that your delta F is 6 kilohertz. All right. So we know delta F, we know Vm. Yeah. So if the modulating voltage is increased to 6 volt, now we have Vm that is 6 volt. What would be the new deviation? All right. So to do this question, so we just use of equation delta F equals to Kf times Vm, isn't it? Kf times Vm. Then we have to identify our Kf lah. All right. So where am I? In here. Okay, so identifying our KF from the information given in the first line. All right. Okay, so delta F 6, so we just need to make use of this equation and then rearrange. All right, so we know what is delta F, we know what is VM, we don't know what is KF. All right, so we need to find KF first. Yeah, so rearrange. That gives us KF is equals to delta F over VM. All right, so delta F is 6 kilohertz, and then VM is 3 volt. All right, 6 kilohertz, and that is 3 volt. That gives us a KF of 2 kilohertz per volt. All right. Okay, if you don't know what is the final unit of measurement for KF, then you should actually. My system is a bit slow. Okay, you should actually put down the unit of measurement for every value that you actually put in your equation. All right, then you actually get the unit measurement will be kilohertz per volt. All right, and then the value is 2. Yeah. So this is what is KF? KF is the sensitivity of the FM modulator, right? So, and this is fixed. For any FM system, the KF is built in, right? Unless you make it adjustable. Otherwise, KF is fixed for any FM modulating system, right? So in this case, when we have a new VM, which is 6 volt now, we need to find what is the new delta F, all right, the new deviation. So the new deviation basically, again, make use of this equation. It's just KF times VM, all right, KF times VM, which is 12 kilohertz. All right, the unit of measurement for frequency deviation is always in hertz. All right, so in this case, because it's in K, so it's just 12K. Okay, then, all right, you may want to take this down first before I move on to question 2. Let me know when you're finished. Yeah. Done? Are you?
Yes.
All right. So let's move on to question 2. So in question 2, you are asked to find the maximum deviation delta F and modulation index MF for an FM modulator with a deviation sensitivity of 6 kilohertz per volt and a modulating signal MT equals to 3 cosine of 18,850 T. All right. So this question basically again is an extension of question 1. all right, where you need to find modulation index. So to do this question, you need to know what is the equation for modulation index. Yeah. So modulation index equation is equal to what? Delta F over Fm, isn't it? So we are given, so we need to find delta F. All right, how do we find delta F? We find delta F by using the equation delta F equals to Kf times Vm, right? Because we have here given this is deviation sensitivity is your Kf. All right, how do you know it's Kf? It's deviation sensitivity. All right, Kf is deviation sensitivity. And if you are not sure, then by looking at the unit of measurement will tell you also. Yeah, because that means that the FM system is going to change 6 kilohertz for every change in 1 volt of the modulating signal voltage. So we know Kf, we need to know Vm in order to find delta F, isn't it? So where is Vm? Vm is by you extract Vm information from the equation of the modulating signal. All right. So from here you can see the peak amplitude basically is this number, right? Because the cosine, as far as cosine function is concerned, the maximum value is 1, right? So that will give us the maximum or the peak amplitude for your message signal to be 3, right? So your Vm is 3, yeah. So that will actually give you your delta F, all right? And then to find the modulation index, you need delta F, which you have already found. Then you need FM, which is the modulating signal frequency, right? And where do you get it from? You get it from here, all right? This number, cosine, whatever t, this number is your omega, all right? So to find the modulation index, you need FM. You cannot use omega m, all right? So convert omega m to FM by dividing this number by 2 pi, all right? So this is all right. So in fact, the solution is very simple as well. Yeah. Um, okay. So as far as frequency deviation is concerned, you just multiply Kf with Vm. Kf is 6K, Vm is 3. So that gives us a delta F of 18 kilohertz, right? And then to find modulation index, you need to use delta F and then divide it by Fm. All right. So how to find Fm? Fm you find from here, as I mentioned previously. Okay, this is your omega m. All right. Omega m basically is 2 pi Fm. So to find Fm, just take this number divided by 2 pi. So that will give us Fm equals to 3 kilohertz. All right. So 18K divided by 3K will give you a modulation index of 6. Okay, have you finished?
Yes.
All right. So let's move on to question 3. All right. So in question 3, we have a FM signal with carrier frequency omega c equals to 2 pi times 10 to the power of 6. Is described by the equation st equals to 10 cosine of omega ct plus 0.1 sine 2000 pi t. All right. So this is the equation for your FM signal. All right. So if you are familiar with the equation of the FM signal, then you'll be able to extract a lot of information from this equation. Yeah. So first of all, you are asked to find the power of the modulated signal. All right. So if you look at the equation, all right, the modulated signal basically is a cosine signal again. All right. So being a cosine signal, again, the maximum value for your cosine is 1, and therefore the peak value for your FM signal is 10. All right. So to find the power of a modulated signal, right, basically our modulated signal is a sinusoidal signal, right? Cosine signal is a form of sinusoidal signal, isn't it? So the power of any sinusoidal signal is equals to the what? If you use V square over R, which is DC, the sinusoidal signal power will be equals to, because it's an AC signal, right? So that will be equals to VRMS square over what? VRMS square over, okay, VRMS square over R, right? And here 10 basically is the peak value, it's not the RMS value. Yeah. So how to find the peak value from the RMS value from the peak value? I actually mentioned this in the lecture, right? So because it's sinusoidal, so the RMS value is just the peak value divided by root 2. All right. So to find the power, then you may ask, you need R information, isn't it? But R is not given here. So as I told you before, if R is not given, always treat R as 1. Yeah. So to find the power, then it become very easy lah. Just an easy equation only. It's just VC square over 2. All right. Why over 2? Because the RMS value is VC over root 2. Yeah. So the power is just V RMS square over R. Eh? Again, we treat R as 1 in this case because it's not given. All right. So that gives us a power of 50 watt. Right. Then next, let me discuss a few more, then you take down. Yeah. Find the frequency deviation delta F. All right. So as far as this equation is concerned, there are two ways to find the frequency deviation. All right. So if you actually recognize this equation, all right, this number here, all right, if you compare to the standard equation of a FM signal with a single tone message, you will be able to tell that this is your modulation index. All right, this is your modulation index. And then again, this is your omega m, all right, or 2 pi fm. All right, so that will give us our fm equals to 1000. All right, 2000 pi divided by 2 pi will give you the fm equals to 1000 hertz. Yeah. Then to find the delta f, again we make use of the equation. All right, so let me show you one way first. Make use of the equation, modulation index is equal to delta f over fm. All right, so to find delta f, you just need to multiply, bring this up here, multiply the modulation index with the modulating signal frequency. Okay, so in this case, it's just 0.1 times 1000 will give you a frequency deviation of 100 hertz. All right, 100 hertz. So this is when you are given an equation where the FM signal has only one frequency component in the modulating signal. If you have more than one, then you cannot use this method, yeah? Then you have to use the more universal method, all right, which is you need to do the differentiation here. All right. So again, if you look at this equation, cosine of something, right, is when you look for cosine, normally the terms is always in angle. All right, cosine of an angle. Yeah. So basically, I actually call this whole term, this whole thing, all right, as an angle. I call it theta I. Theta I being the instantaneous phase angle of the FM signal. Yeah. So this is given by omega ct plus 0.1 sine 2000 pi t. All right. From here, this is the phase angle of your carrier signal, and this is the change in the phase angle of your FM signal. All right. So the change in phase angle of your FM signal. So this is delta phi, and this is what I call phi c lah. So this plus this will give me the instantaneous phase angle of my FM signal. All right. And then to find the instantaneous frequency of the FM signal, I have to differentiate the phase angle with the time. All right. Basically, you know, right? Omega is d theta over dt, isn't it? Right. So I have to perform differentiation here. So differentiate omega ct, I get omega c. All right. Differentiate a sine. Basically, I get a cos. All right. And then because here there is a constant inside, so I have to bring this up lah. So that we multiply. All right, 2000 pi multiply with 0.1 will give me 200 pi. Okay, so this course basically require you to make use of some of the calculus that you have learned before. All right, nothing new here. So what gives us here is again the instantaneous frequency of the FM signal consists of the carrier frequency plus the change, all right, the change in the carrier frequency caused by the modulating signal. All right. So, and this is what I call delta omega. All right, delta omega is the change in the carrier frequency caused by their modulating signal. All right. So here delta omega is equals to, this is 200 pi cosine 2000 pi t. All right. Again, what is the maximum change? What is the maximum change here? The maximum change is when, again, the cosine value is 1. All right. So when cosine term is 1, that gives us the maximum deviation. All right. And the maximum deviation here is in delta omega. All right. And this is 200 pi. So the delta f, which is the maximum change in frequency, the linear frequency basically is take the delta omega divided by 2 pi. That will give us your delta f. All right. That will give you a delta f of 100 hertz. Okay. You may want to take this down first. Okay, finish.
Yes, Miss.
All right. So and then next question asks us to find the modulation index. All right. So if you have used this method to find your delta F, then you just calculate your modulation index with the equation where MF equals to delta F over FM. All right. And that should give you a modulation index of 0.1. Yeah. You can also say that from equation, you straight away know that MF is 0.1. Yeah. Then the next item is to find the phase deviation. All right, phase deviation. Phase deviation is delta phi. All right, and delta phi is this one here. This is your delta phi. So again, what is the maximum phase deviation? The maximum happen when your sine term is 1, isn't it? Yeah, when your sine term is 1, that's where your maximum phase deviation happen, and that will be 0.1. All right, for phase angle, 0 is the unit of measurement is always radian, yeah, 0.1 radian. And then last part is asking you to find the bandwidth, estimate the bandwidth. So this question never say how to estimate it. So you can estimate it, just make use of Coulson's rule, right? Make use of Coulson's rule and then which is 2 times mf plus 1 multiplied with fm. So put in your numbers for um, your modulation index and value for FM, then you get your bandwidth equal to 2.2 kilohertz. Okay, and because zero, if you try to find the n values um, for mf equals to 0.1 in the Bessel function table, you will not be able to locate it. All right, and then there's another way also, because if you look at the modulation index is 0.1. All right. So when the modulation is index is 0.1, it's actually a lot smaller than 1. So you can say that this is a narrowband FM signal. All right. And then you use the narrowband FM signal bandwidth equation, which is 2 FM. All right. And that will give you 2 kilohertz. Okay, both methods are acceptable, but you must, if you don't use you must say when you want to use Coulson's rule, then you need to write down what is Coulson's rule and then put in the value and get your answer. But if you want to use the bandwidth equals to 2 FM equation, then you must state why you use that equation. All right, and the reason being your modulation index is very small, right, as compared to 1. So it's actually a narrowband FM. Yeah. So narrowband FM bandwidth equation is 2 FM. All right. If you want to do that, it's fine as well. Okay. Take this down. And then after this, I would like you to try out question 4 on your own. All right. Question 4, the question is very similar to question 3. Okay, copy down first. Then I explain a bit of question 4. Okay, finish. Have you?
Yes.
All right. So let me talk a bit on question 4 first. All right. So in question 4, You can see that your FM signal now, all right, contain two frequencies as far as your modulating signal is concerned. All right. So the modulating signal now consists of two frequency components. All right. So therefore, you cannot use the you cannot say this is MF or this is MF. Okay, neither one of them is MF. All right. To find the MF or modulation index, you have to find your delta F first. All right. So meaning you have to use the approach of differentiation. All right. Differentiate this whole term to find your delta omega. All right. And then the maximum happen when both terms are when you differentiate sign, you get cosine from both sides. All right. When the both cosine terms are 1, that will give you the maximum. All right. Then you find your frequency deviation from there. All right. You find your frequency deviation from there by the differentiation method. Yeah. Then modulation index is to take what delta F divide by FM. So now which FM you got? Now you got two frequency for your modulation signal or your modulating signal. Which frequency shall you take?
The highest.
Yes, yeah, good, the highest. Yeah, always take the highest frequency as your FM. All right, and then same thing for phase deviation. All right, you're going to end up, you see you got two delta. The whole thing actually is your delta phi. All right, again, when is it maximum? Right? Again, what is the maximum value? You can straight away tell from here, isn't it? Right? So I'll allow you to do it on a piece of paper. And then after you're done, scan it with your handphone and upload to Google Classroom. All right. I've created an assignment called T3Q4 in Google Classroom. So you upload it there. All right. Can. So I will wait for you to upload and then I will mark it there and then I will give you a comment. All right. I'll give you a private comment to tell you whether you got it right or you got it wrong. All right. Then you check your answers from there. Boleh ah?
Boleh, boleh.
Good. While you are working on it, I'm going to take attendance. So please respond when I call your name. Happen. Intranet is down. Oh my god, intranet is down, so I have to find a way to mark your attendance. Okay, Yong Chi Ye, are you here?
Yes, Miss.
Han Xiang?
Hello.
Yeah, I heard you. Han Xiang?
Yes, Miss, I'm here.
Wu Heng Dong?
Yes, Miss, I'm here.
Tan Xin Sen?
Yes, Miss.
Wong Ka Shing?
Yes, Miss.
Thieu Leong Ho?
Yes, Miss.
Ong Mei Lin?
Yes, Miss.
Ng Wei Hong?
Yes, Miss.
Lim Wen Yang? Lim Wen Yang, where are you? Lim Wen Yang tak ada. Yong Wen Liang,
Yes, Miss.
Pang Xue Wen, Pang Xue Wen, Pang Xue Wen might spoil already. Might spoil you respond in your chat box. All right. And who's next? Pang Xue Wen, So Yan Chang, Hua Yihang,
Yes, Miss.
Teo Yi Si.
Yes, Miss.
Okay. So who is not here? Lim Wen Xiang. Lim Wen Xiang, are you back? Lim Wen Xiang missing in action. Okay, so Lim Wen Xiang is absent.
Miss, actually, Wen Yang is group 1.
Lim Wen Yang is group
yeah,
1.
it's group. Yeah, he's supposed in group 1.
But why he joined here?
Want to learn again, I think.
But why he so quiet? Okay, so okay, no wonder I have 15 people here. All right. Because the intranet is down, so I cannot access your name list on the intranet. So I just call names based on your login names.
And
Okay.
also got one more Lu Jieming's. Miss haven't called him.
He didn't log in. He didn't
I
sign
think
in.
yes. Below Tan Shin Shen.
Oh, okay, I missed. Sorry. Lu Jiamin. Okay, Lu Jiamin. Lu Jiamin, why you keep quiet?
Yeah.
I missed the name. You should tell me. Or else later I mark as you the absent.
Oh, okay.
Okay. All right. Okay. So I'm waiting for your answers at Google Classroom. Make sure when you do your calculation, when you reach when you arrive at the last answer, please make sure you put in the unit of measurement. All right. Unit of measurement is very important. So don't just give me the number. Unless it's like modulation index, no unit of measurement. Okay, then you just give me the number. But if but like delta F, frequency deviation, right? What is the unit of measurement for frequency deviation? What is the unit of measurement for bandwidth? All right, all must have. Hmm? Hey, Yongqi, are you from this group? You already submitted your T3Q4 in the previous session.
Sorry, Miss.
You, I actually saw your submission in the Google Classroom from previous session already. So you attend 2 session?
No. Because during that time when Miss posted there, I thought we need to submit also. So since I already done, so I just submit.
Oh, okay.
Yeah.
All right.
Miss, I also miss.
Oh, you also? Oh, okay.
Yeah.
No
This I
wonder.
also.
Oh, good. Very hardworking. Oh, yeah, on Kashin. Yeah, I saw yours. I remember. I was wondering.
That's why I don't know how to do the face duration.
I see. Okay. So now you know,
Yeah.
Okay. Okay, I can see some of you have already submitted, and I have also marked and returned with a private comment. Okay, well, while you have finished, and then I believe you got nothing to do. Do you have any questions that you want to ask me? Nothing there. Hey, Pang Xuewen, don't give me a picture. Next time, make sure you submit in PDF form. Picture very difficult for me to mark. Hey, Pang Xuewen. Mm. Pang Xuewen, I have returned your work with I've put in a private comment on your work. Can you please check? Wow, your answers are coming in very slowly. What? You all was looking for paper and pen. Hey, every time you attend my class, make sure you have pen and paper handy, you know. Anytime I can ask you to write something and upload one, you know. Okay, and for those who have submitted and then you got no question to ask me, you may leave first. All right, so, and then for the rest, I'll wait here until you have submitted, or when time is up, then make sure you submit within today. I'm sure you'll be busy with something else afterwards.